So this is Gavin. This is part A of the BJT lab. So here we have our current source, but now it's hooked up. Well, this is the first time you're seeing this. So now it's hooked up to the lab equipment here, and we have 15 volts as the source, VCC. And so this is our potentiometer. If we take the voltage across the collector, then here we see it's 6.9, and right now we have resistance of about 1.8 kilo ohms. And so the whole point of this is that no matter what, if you change this resistance up or down, then the voltage will adjust in order to have the current through it be always the same, because it's a current source, and you can put whatever resistance here you want, but the current coming out is always the same. So yeah. So here, this is part B though. So here we have the current source, and so this is our variable resistor, our potentiometer. This is our actual NPN transistor, and then we have these resistors here going from the base to ground through some resistance, through the emitter, and then through resistance to ground, and the base also in parallel with a resistor to the source. And so I measure VC, which is the voltage from the collector, and so VC right now is 2.15 K, 2.15 volts, and the current RL value we have is 1.8 kilo ohms, and as we change RL, the voltage always changes to compensate so that the current going through that resistor is always the same. That's why this is a current source, because no matter what you change that resistor to, the current will always be the same, so it's going to continuously supply that current. So then we can measure VE through the emitter, and that's 1.59 right now, and that is always the same no matter what RL value we choose. So then here, the second part, or the third part of this lab was this, which is the voltage amplifier. And so we have our transistor, and then we have this, which is two resistors in series to create a 2 kilo ohm resistor and then a 1 kilo ohm resistor out of the emitter. And what this does is we're putting in a signal into the base, and then it gets amplified based on the ratio of this, and also inverted. So here we have 2-to-1 ratio of RC over RE. So the amplification and the gain is going to be 2. And so we can see that here. This is our scope that we're running our signal on. And so we can see that this is our input, and then our output is shifted out of phase 180 degrees and then amplified by a magnitude of 2. And so then if we do a network sweep, we see that the gain is here, is positive, and then at really high frequencies the gain drops off. And so also another thing about this is if there were a DC offset, then the DC would kind of shift the whole output up to whatever that offset was, but in this case we have no DC offset, so the output is just the pure magnitude of the gain times the input.